All right, everybody, welcome to Module 3 of the Circuits 2 class, EE221. This is on power analysis and three-phase circuits, and we'll just get right into the lecture overview. I'm going to hit on the topics that we're going to cover in this module real briefly, and then we'll end this video and we'll get right into the RMS values section. Okay, so first we're going to talk about RMS values. Sometimes it's also called the effective value, but RMS is much more common, so that's what I'm going to go with. We'll talk about what RMS values are, average values of signals and things like that, which are really relevant to power analysis. Okay, and then we'll talk about energy and power here, how energy and power are related, what is power and how do we measure it, how do we calculate power supplied by a source, how do we measure and calculate power dissipated by a load, etc. We'll talk about the difference between instantaneous and average power. We'll talk about real power versus reactive power, and then we'll talk about complex power, which is defined and governed by this thing called the power triangle, which is really interesting and pretty intuitive. And then lastly, we're going to get into three-phase circuits and systems, which is something that will maybe look scary at first, but I think that you'll probably find that it's not as bad as what it looks like. We'll look at different ways that you can connect three-phase sources and three-phase loads, all the possible configurations. There are 4 of them, and then we'll do some example problems. Okay, so I'm going to go ahead and end this video, and without any further delay, we'll get right into our section on RMS values.